Okay, adding vectors at an angle. Not all vector movements go in one-dimensional planes, either west or east, north and south, up or down, left or right. So everything that we've done up until now has always gone along one plane. Okay? So we've either dealt with drawing vectors going west to east or east to west, or just north and south, okay, and then south to north. So what we're going to be looking at is now what happens when we include all the compass directions, including the ones in between, right, that go at an angle. So if the direction does not exactly match one of the compass points, we write it as an angle from the closest compass point. Okay. So when drawing our resultant displacement vector, same rules applies as in one-dimensional vectors. We always draw from where we start to the point in which we finish. The only thing is, this time, we might be going at an angle. Okay. So, here's our delta D1. Okay. According to what we assume if we had it included the compass, we're traveling in an easterly direction. But now what happens if we choose now not to move along the same plane, but we decide to move in a northerly position? So, where did we start? Well, if we look at where we started along this is the point in which we started from. This is our starting point. This is, over here, our finish point. So our delta dr is going to be drawn from where we start to where we finish. And so now, this is the line that you'll be measuring. But before, we were able to use the algebraic model to find the length of this diagram. But that old model of delta D1 plus delta D2 plus delta D3 that we learned in the previous lesson will not work. However, we can use some other mathematical model. What's that? What can we use? Yeah, the Pythagorean theorem, exactly. So we can use that, but that's only if we create what kind of a shape? Right angle triangle. Measure the angle from one of the four compass directions and specify which side of that direction your line is on. So the vector's direction is written as 30 degrees east of south. So we have here the compass. So we are traveling from east from the south direction. So, here's how it's drawn. We go from whatever this position was, our southern position, and we line up our 0. So you're going to line up your 0 degrees of your protractor along the second one of the two angles, because that's where you're measuring it from. And we're going east, right? We are traveling east from whatever that south direction is. So that's how it's read. So we're traveling easterly from the south position. That second point is where we're going to label as our 0 point on the protractor. Okay. So let's look at another angle here. So, let's look at the following here. We label our 0 point here on the protractor. And we are traveling now southerly from the east position. Okay. So, here, whatever the angle is, if we were to measure it, will come out to about 60 degrees. Notice here where we said, our second point, this is where our 0 degree marker is. And we're traveling south from wherever that 0 direction is. Okay. Everyone follow me? Now, we are traveling what direction from where? So we're traveling from the north. So north is where we put our 0. We measure this angle. And what direction from the north are we going?
West.
We're going west. So in this case, 30 degrees west of the north position. And then here with this last one, if we were to measure this angle, we are traveling however many degrees, right? From, where's our zero? Our zero here is at the south, and we are traveling in a westerly direction. So we are traveling west, okay? Traveling west from a southerly position. But because the angle is right at a 45-degree angle, we don't need to worry about the angle. Whenever we write down southwest, northeast, northwest, or southeast, it means that the angle is exactly at 45 degrees. That is the only time we do not use this method here. Yeah?
Sir, I didn't understand why you said we don't use the top example, from south to west.
Okay. The reason for that is because it's exactly at the 45-degree angle. Whenever we use the 45-degree angle, we don't write it in that format.
Okay.
We don't use this. There's no need to put in the angle with the direction, because if we know it's 45 degrees, we know it's right at that point. Right at the southwest, northwest, northeast, or southeast. That's the only time we don't use it. Yeah.
That's just taking place of like the direction it's already there.
That's
Just
exactly.
like the length and all that.
Exactly. So what, if we had, right, here's, okay, our delta D1, as we had in the first example. Here's our delta D2 that we had in our, for the second movement. And then our delta dr, our delta dr is what we're trying to find. Now, where would we put our 0 point to mark this?
Delta D1.
Right along this delta D1.
Start of the...
Right? So according to our compass, what direction are we starting it from? What direction is this 0 line going to be at? East. Right? So our 0 here, degrees, and we are traveling in what direction of east? What direction are we traveling? North of the east. Okay? And it's that angle that we're trying to find. Right? It's that angle that we're trying to find. So we're going to place our protractor, and then we line up the 0 of our protractor along here. Now, there's another option that we can use. The other option is, if we decided to draw in our imaginary north, because technically the delta dr, if we use it this way, our 0 marker, our 0 degrees is here at the north, and we're going east of the north direction. But the only thing, the reason why I don't suggest this one is because now we have to add in an extra line from into our drawing. We want to try to use the lines that we're given when we're drawing our resultant displacement and using our protractor to measure the angles. Okay. So we'll work on a few before you panic, because I know this is the part that seems to give several struggles. Okay. So here's the direction. So if you want, you can actually remember the following angles. Okay. So we have at these ones here, northwest, northeast, southeast, southwest. These are all going to be at the 45-degree angle. But the minute we go beyond 45 or smaller than 45, we're either looking at, we're going north from the west direction, or if we're measuring this angle, we are going west of the north direction. So remember, as we said, this second one here, all these second parts, these when we have the two sets, This is represented with the 0 degree mark. So that's where you place the 0 marker in order to give yourself whatever the angle is. Okay. And the first one is the direction we are moving from that 0 marker. So here we have east of north. Right? So we're going, so north is our 0. So this is where we put the 0 marker. And we are traveling east from whatever that marker is. So whatever that angle happens to be, whatever that delta dr happens to be, right, we are measuring it from that northerly direction. And sometimes we might need to draw in the lines. Okay, we might have to draw in our 0 marker, but we'll go through that in an actual example as we move on and we look through some of the worksheets. Okay. So let's look at the first example here. Denise walks to Jean's home by going 1 block east and then 1 block north. Each block is about 160 meters long. What is Denise's final displacement? So first thing you want to start off with is your compass. Okay. After your compass, your scale. So the scale, what we're going to use is 1 centimeter is equal to 40 meters. When you're drawing it, remember, we want to start by listing pretty much all our movements, or all our displacements. Okay, so delta D1, 160 meters east. Delta D2, 160 meters north. So we have our delta dr, 160 meters represented east, and then north. Now, what's really important is you want to make sure that what angle are these two going to be? Right angle, right? So make sure that with your protractor, that you do measure that it is in fact a 90-degree angle, because you know it's going to have to be that. Because if it's not, it's going to change your answer, or your overall answer. And now we're going to draw our delta dr from where? It goes from start to finish. So you find your starting point and your finishing point. And now what you're going to do is with your ruler, you're going to measure your delta dr. With your ruler, you're going to measure your delta dr. Because we know that mathematically we can use Pythagorean theorem to get our answer. But I want to know that based on your diagram, I can still get the same answer. Because remember, if I'm evaluating you based on your drawing, and your drawing is not to scale, you will not get the marks. Because if you're being evaluated on your drawing, and your drawing tells me that it's a different delta dr, but your final answer tells me it's the proper delta dr, then you really didn't get the proper delta dr based on your drawing. And that's what you're being evaluated on. Okay? So with your drawing, your line should come out to about 5.65 centimeters. Approximately around there. Obviously, it might be a little bit tougher to get into the hundredths column, okay, for a measurement on your ruler. So based on the scale, that length should be represented by 226 meters once you converted it using your scale. Okay, but that's our delta dr, but that doesn't tell us what direction. Right? We want to include a direction. So did we go north, south, east, and west? In fact, we are now going at an angle. So where would we put our 0 marker of our protractor? Where will we put it?
At the tail of delta D1.
Okay, so this would be our 0 degrees. And from there, we are going in what direction? What direction am I going?
North of east.
I'm going north of an east direction. What's the angle in which I'm going north of east?
40 degrees.
40 degrees?
44.
44, 45. In fact, it is right at a 45-degree angle. Okay? It should be right at a 45-degree angle. And because it's at a 45-degree angle, so here we have 45-degree angle north of east, right? Pretty much using the units that you guys have said. But look at the second one here that I have. 45 degrees east of a northerly position. Where is my zero of my protractor? Where did I put the zero? Remember, the zero always goes with the second of the two units when it's written in this format. So we are traveling east from a northerly direction. But because it's at a 45-degree angle, we just write it down as northeast. So therefore, the resultant displacement for Denise's walk is 226 meters northeast. The reason why there's no angle, what's the angle? 45 degrees. If it was 44, you'd have to state that. Now, another thing to make note of, if we were writing these angles, the only time you put them side by side like that, northeast, is if they are going at a 45-degree angle. Otherwise, it's always either going to be north of east or east of north. So it's something of something. You will never write the angle, you'll never write an angle as 30 degrees northeast. Okay? It would be 30 degrees north of east.